3.2 Properties of Parallel Lines. This is one of my favorite sections and one of my favorite chapters. Our objective in this lesson is to prove theorems about parallel lines and to use properties of those parallel lines to find angle measures. Now, if you remember from last lesson, we had special angle pairs that were formed by two lines being intersected by a transversal. Well, now we are intersecting parallel lines by a transversal, and those angle pairs are going to be very special. They are going to be congruent or supplementary or both sometimes. Okay. Let's take a look at our first postulate here. First postulate is called the corresponding angles postulate, and we can shorten this one to corresponding angles postulate. We know we like to shorten things down. And it says, if a transversal intersects two parallel lines, now that's our requirement. We have to have two parallel lines being cut by a transversal. So if we look over here at our diagram, I see parallel lines, right? We have our parallel markings there, and they are being cut by the transversal. Remember, I told you if you color your transversal, you always know where it is. And look, now we can see that we have those angles, those special angle pairs that lie on that transversal. So these are things that we're actively looking for in our diagrams. Are these parallel line markings, or we can be told that line L is parallel to line M. Parallel is a good thing. You want that to be happening. So if we meet our requirement here, we have two parallel lines and they're being cut by a transversal, intersected by a transversal, then corresponding angles are congruent. Oh, that sounds special. And which ones are the corresponding angles? Remember, corresponding angles are in the same place, same position. So let's look for our corresponding angles here. Angle 1, well, it is above the parallel line and left of the transversal there, so I go down to my other parallel line. And angle 5 is in the same place. So angle 1, I can say angle 1 is congruent to angle 5 because of the corresponding angles postulate. And we can do the same with angle 4 and angle 8, angle 2 and angle 6, angle 3 and angle 7. Right, all of those are corresponding angles. They are in the same position. Our requirement is met. Two parallel lines intersected by a transversal, corresponding angles, and I'm going to put congruent up here so when I look back, you know what? We are going to put that in red because that's kind of important. That is something we want to remember. Corresponding angles are congruent when our requirement of parallel lines is met. So let's look at our example here. It says, which angle measures 55 degrees? How do you know? Well, that angle measures 55 degrees. It's given. All right, we're looking at this angle here. So we are given that that would be angle 3. The measure of angle 3 is 55 degrees. Well, do we know any others? Well, I'll take a look at my diagram here, and I see parallel lines. I'm going, oh, that is a good sign. And then I'm going to color in my transversal. And remember, I told you, if you're having difficulty seeing these, our example up above, the parallel lines are horizontal. So if you're having difficulty, just take your paper and turn it 90 degrees and then compare it to your diagram. Those opposable thumbs are awesome. We can turn our paper and it will help you. You'll see all of the angles there in the same position. But I think we're okay. If you mark your transversal, you can see your angles there all lined up on your transversal. And so who else is going to measure 55 degrees, and how can we justify that? Well, the measure of angle 7 is 55 degrees, and it's because of our new postulate, the corresponding angles postulate. So I can mark that 55 degrees. Are there any other angles that we could say are 55 degrees? Well, hopefully this jumps right out at you. You should see vertical angles here. So the measure of angle 1, we can say angle 1 measures 55 degrees as well by the vertical angles theorem. And then, in addition to that, we can go up here and say, hey, I have corresponding angles. Measure of angle 5 is also 55 degrees by the corresponding angles postulate. So look at all those angles that we have named already. Hopefully you're really wanting to name the others. So let's do that. Go ahead and pause the video and do the example problems. All right, let's take a look at these. First one says, can you find another way to justify that the measure of angle 5 is 55 degrees? Well, yeah, we saw it with angle 1. Angle 5 is congruent to angle 7 because of the vertical angles theorem. So we know that angle 5 also measures 55 degrees. That's just simply the definition of congruence. And part B, using linear pairs, find the measure of angle 4. Okay, so I just kind of redrew my little angle 4 and my 55 degrees, or angle 3 that isn't labeled angle 3, and that's a linear pair. So I know that the measure of angle 4 plus 55 degrees equals 180 degrees, so measure of angle 4 is 125 degrees. Are there any other angles up here that measure 125 degrees? Well, I labeled my 125. And I am looking here, and 4 and 8, by golly, those are corresponding angles, so 125 degrees. I could put 2 angle marks on those, right? And what else do we see? I see vertical angles again, so 125 degrees. And for angle 6 and angle 2 is also going to be 125 degrees. It is either vertical to 4 or corresponding to 6. So do you see how special these angles are here on our parallel lines cut by a transversal? All right, well, let's continue on. You're going to see a pattern here with our 4 special angle pairs. And all of these are kind of based on the corresponding angles postulate, so keep in mind our diagram up there with what we just did. This is going to be one of our most used, most favorite theorems, the alternate interior angle theorem, which we can call the AIA theorem. Okay, alternate interior angle theorem says that if we have our transversal intersecting our parallel lines, 2 parallel lines cut by a transversal, all of these are going to have the same requirement. There's my transversal. I like to know where it is. Then my alternate interior angles are congruent. So let's put that up here. So that's going to be nice. We like congruent angles. It helps us out. Definition of congruence tells us they're going to have equal measures. So who are our alternate interior angles? Well, angle 4 and angle 6 are alternate interior angles. So I can say angle 4 is congruent to angle 6. And angle 3 and angle 5 are also alternate interior angles. I can say angle 3 is congruent to angle 5. And you know that the definition of congruence is going to let us say things like this. The measure of angle 3 is equal to the measure of angle 5. this is by definition of congruence lets us say that. That is why we like congruent angles. And our next one here, this one's useful. We will use it frequently as well. Not as much as our alternate interior angles, but we use this one a lot as well. Same side interior angles. We can call this one SSI angle theorem. Same side interior angles. If we meet our requirement, transversal intersects our parallel lines. So let's mark our transversal. There's our parallel lines. Same side interior angles are going to be supplementary. So let's put a big supplementary up there for our SSI angles. And who is same side interior? 4 and 5, 3 and 6, because we are on the same side of the transversal, in between, inside the parallel lines. So we could say those are supplementary. So look what that lets us say. This is by definition of supplementary, right? We know that those angles are supplementary. Definition of supplementary lets us say that the sum of the measures equals 180 degrees. So very useful to us. Now, both of these are theorems. If we look back up here, our corresponding angles was a postulate. Oh, we should add this on up here too. Definition of congruence lets us say what? That the measure of angle 1 equals the measure of angle 5, right? And that's true for all of those. All right, corresponding angles was a postulate. Postulates are accepted as fact. But if we look down here at these, alternate interior angles and same side interior angles are both theorems. So both of these are proven. Let's take a look at the proof of the alternate interior angles theorem. So what are we given? We always look at our given. We are given that line L is parallel to line M. So there's our parallel marks. We know that those are parallel. We want to prove that angle 4 is congruent to angle 6. Okay, we can do that. So what do we have here? Let's go through our ideal. And right here, 2 and 4, I see vertical angles. Do you see those vertical angles? Those just jump out. And what do you see between 2 and 6? I see our corresponding angles postulate. So we've got vertical angles theorem, corresponding angles, and how are we going to connect all these together? Well, angle 2 is related to angle 4, and angle 2 is related to angle 6. That looks like transitive property to me. So let's go through our proof here. We are given that our lines are parallel, and they're cut by this transversal. So we've met our requirements. We can say that angle 2 is congruent to angle 6. So angle 2 is congruent to angle 6. That's our corresponding angles postulate. You can write it out, or you can just use its name. I like using its name. It's much shorter. All right. And then we can say that angle 2 and angle 4 are congruent. And we said that that is by the vertical angle theorem. You can write it out. Vertical angles are congruent, or you can write its name. And then if we look here, that's not the color I want. We have that common part. Now, is this substitution or is this transitive? Well, these are two separate ideas So if we are going to smush them together here, if we're going to take out that middleman and just leave 4 and 6, that's the transitive property of, and this time it's congruence. Make sure you're using the right transitive property. So this is a very simple proof that lets us do alternate interior angles theorem. And there's very similar proof for all of the others. Let's look here. How do you think that we could do same side interior? Well, we could use our vertical angles and our corresponding angles, and we have some linear pairs as well. Do you see the linear pairs? If we used angle 2 right here, we have a linear pair and corresponding. We know that 2 and 3, angle 2 and angle 3 are supplementary. That's our linear pair postulate. And angle 2 and angle 6 are congruent by corresponding angle postulate. And what do you see? We can say that angle 6 and angle 3 are supplementary. This time it's substitution property. Right, do you see what we did there? I've got a 2 in both of these, and I just took 6 and threw it in there. We could have written this better. Angle 2 is congruent to angle 6. There we go. That's our corresponding angles postulate. And then I can just substitute in 6 for 2, and now 6 and 3 are supplementary. So very simple proofs here using things that we already know, our vertical angle theorem and our linear pair postulate. So let's look at doing a proof. What are we given? We are given A is parallel to B, and that makes us very happy. And if you like, I always recommend it, mark your transversal, because then you can see how the angles relate to each other, right? They're all laying on that transversal. We want to prove that angle 1 and angle 8 are supplementary. Well, what do we know? We know that angle 1 and angle 8, or angle 1 and angle 5, are corresponding angles. So we're going to have angle 1 is congruent to angle 5, right, by our corresponding angles postulate. We could mark those. 1 and 5 are congruent. And what else do you see? Do you see that we have, and let's redraw here. We like to redraw. We're going to start redrawing things. We've got 5 and 8. That's an 8. Do you see that linear pair? We have a linear pair there. So 5 and 8 form a linear pair, and what is that going to mean to us? That's going to mean that they're supplementary. And we're starting to see, hopefully you can see here, how we're going to get 1 and 8 are supplementary. So this is just going to be substitution, right? Because if we know that angle 1's congruent to angle 5, and angle 5 and angle 8 are supplementary, they form a linear pair, we can just substitute in. So let's look at our proof of this. Our proof is down here a little bit. We're going to push down a little bit. So do you see how we did all of our defining, marked our angles, redrew some things? So we are given that line A is parallel to line B. Right there, that's just a given. And then angle 1 is congruent to angle 5. And we said that's just the corresponding angles postulate. Again, you can write it out or you can write its name. And then the measure of angle 1 equals the measure of angle 5. How can we say that? How do we go from congruent to equal measure? That's simply just the definition of congruence. Remember, these two steps frequently go together and they can go either direction. You can go from congruent to equal measure or equal measure to congruent. And then we also know that 5 and 8 are supplementary because of our linear pair postulate. Angles that form a linear pair are supplementary. And so what can we say about that? Well, we can say that their measures sum to 180. That's just simply definition of supplementary. And then what are we going to do? We are going to take the angle 5 here and substitute in angle 1 because we know that they are equal. We take this step and just use it right there and substitute. And then we can say that angle 1 and angle 8 are supplementary simply by definition of supplementary. If their measures add to equal 180, that's definition of supplementary. So it looks a little challenging, but I believe you can work your way through proofs like these. You just have to stop and think about it, and if you set it up in your Define Explore section, your life will be much better. All right, it's time to pause the video and do your proof. Good luck, I know you can do it. All right, hopefully you worked through that. I'm going to work through it here with you. And I redrew my diagram, and we are given that line A is parallel to line B. I marked my parallel lines. And I see here angle 1 and angle 5 are going to be congruent. That's because corresponding angles postulate. So I'm just going to make a little note here. Corresponding angles. And I also see 5 and 7. How do we know those are going to be congruent? That's our vertical angles. And so what do I see? I see those right there. That looks like a transitive property to me. We are trying to prove that angle 1 is congruent to angle 7 all the way over there on the outside. Can you name what kind of angles those are? Those are our alternate exterior angles, aren't they? They're on the outside of our lines intersected by our transversal, and they're on the opposite sides of the transversal. So let's turn this into a proof. We know, step 1 here, that line A is parallel to line B, and that is simply given to us. And that tells us a lot, and it's cut by transversal. Always good stuff to have. So step 2, I am going to say that angle 1 is congruent to angle 5, and that is because of my corresponding angles postulate. And now I stop and look here. Do I need to get the measures equal? I don't think I do, because we are simply going from congruence to congruence. Our final answer here is in congruence. If we need to, we can do it later, but I think we'll probably be okay. That definition of congruence is always available to us. So let's do step 3 and say that angle 5 is congruent to angle 7, and that is by our vertical angles theorem. We love that one. Okay, and then we see right here that those two are common to both of these, so I can say angle 1 is congruent to angle 7, and that is the transitive property of congruence. Lets me mash those together. And I'm done. So we didn't need to use our definition of congruence, but we should always be thinking that it's there. We can go to our angle measures if we need them. All right, that was a fun little proof. Hopefully you're starting to see how the proofs are going together. You will be getting better at them. You have to be actively looking for all of our definitions, postulates, and theorems though. So review those on a regular basis, because chapter 1 never leaves us. Neither does chapter 2. All right, our third theorem here is the alternate exterior angle theorem. AEA theorem is how we can shorten this one. And it says if we have our transversal intersecting our parallel lines, notice the requirement is exactly the same for all of these. It's awesome. Then what do we know? Our alternate exterior angles are congruent. And if you look, we just proved that, didn't we? We just proved that alternate exterior angles are congruent. So we did very good, right? We proved angle 1 is congruent to angle 7. And we have angle 2 and angle 8 are alternate exterior angles. So we are going to put congruent in red over here for our reference. And what does that let us do? Well, if 1 is congruent to 7 and 2 is congruent to 8, don't forget that we can always use definition of congruence to say that the measure of angle 1 equals the measure of angle 7 and the measure of angle 2 equals the measure of angle 8. Don't forget that congruence and equal go together. All right, what fun can we have with these? If you know that the measure of one angle, formed by your parallel lines in a transversal, you can use it to find the measures of other angles. So let's take a look at our diagram over here. I see parallel lines all over the place. L is parallel to M. And look, it's cut by 2 transversals. So we can be looking at these parallel lines cut by that transversal and these parallel lines cut by that transversal, right? It means we have special angle pairs on both of them. But look what else we have. We have parallel lines over here. So we are also looking at these parallel lines cut by this transversal and these parallel lines cut by this transversal. So a lot of stuff going on here. That means that we have our special angle pairs up and down as well. So you might have to look around for some of this stuff. You might have to redraw. Notice that I redrew all 4 of our parallel lines cut by a transversal, and that might just make it easier to deal with. All right, we want to know the measures of angle 3 and 4. Which theorem or postulate justifies your answer? Well, who do we have here? We are given this angle right here over on the right-hand side down at the bottom is 105 degrees. What do we know about angle 3? Well, there's my 105 degrees. If I am using this one right here, right, our 2 parallel lines, this is now my transversal. Okay, do you see it now? 2 parallel lines cut by a transversal. Then measure of angle 3 is also going to be 105 degrees because those are alternate interior angles. So we can label that 105 degrees. All right. What about angle 4? Erase that. How are we going to relate angle 4? Well, it's right here. And is there something we can do about that? Well, let's make this our transversal. So now our angles are sitting on our transversal, and we are dealing with this one. And our angles are right there. Well, which angles are those? Those angles are same side interior angles. And what do we know about same side interior angles? We know that they are supplementary. So we can find out that the measure of angle 4 is 75 degrees. I'm going to take out my transversal there. Okay, so we have those labeled. And did you see how marking the transversal makes it a lot easier to see how the angles are related, especially when we have multiple parallel lines and multiple transversals here. All right, pause the video and do the next set of problems. All right, a lot going on this one. Many ways to do this. Again, thank you, Geometry, for having 27 different ways to do the same problem. Angle 1. How did we find that? Well, it is congruent to angle 4 by alternate interior angles. And so it measures 75 degrees. And then we move on to angle 2. Well, how do we get angle 2? Well, angle 2 is congruent to angle 4 by corresponding angles, or angle 2 could also be vertical to angle 1 there, right? So it's either corresponding to 4 or vertical to angle 1. Either way works for us. And then let's look at angle 5. Well, angle 5 is corresponding to the original angle, so it's congruent to the original angle, or it can be vertical to angle 3, which we found earlier, or it can be same side interior to angle 2, which we just found. Angle 6, well, it is also alternate interior to our original angle, or it is corresponding to angle 7, which we haven't found yet, but is corresponding to angle 7. And angle 7 is corresponding to angle 3, which we found earlier, or it is also vertical to the original angle. Right? So multiple ways to find that. Angle 8. Angle 8, we could do a lot with angle 8. By this point, we've got everybody else. It is corresponding to angle 6. It is also same side interior with angle 4. It is also a linear pair with angle 1 and angle 2. So by the time you get around to the last angle or two, you've got many ways to find all of these. But hopefully you're seeing a pattern here. We only have 2 angle measures, 105 degrees and 75 degrees, because we are dealing with linear pairs, right? Just lines. So we know they have to be supplementary and add up to 180. And we're dealing with vertical angles. So they have to be congruent. And that's all that we really have here are linear pairs and vertical angles. And if we can move it to the next parallel line using corresponding angle postulate, all of the rest of them, alternate interior, alternate exterior, and same side interior, all fall into place. So I really think these are fun. Hopefully you will like them too. Okay, get to the end here. You can combine theorems and postulates to find angle measures. Yay! Right, let's look at our diagram here. We want to find the value of y, and I immediately see parallel lines, and I see two sets of parallel lines here, or I see a set of parallel lines cut by two different transversals. So let's figure out which transversal is going to help us, and we can extend our lines, right? That doesn't stop there. It's a line. It goes on forever. So if I am just looking at these two parallel lines, I like purple for my parallel lines, cut by this transversal, is this going to help us? Well, 40 is the only angle that's actually on that transversal, because if you look at y only goes to there. Y doesn't go this entire distance. So that transversal doesn't really help us. So we can take that out. Let's find a different transversal that'll help us. What if we look at this transversal? Do we have all of our angles on that transversal? We do, if you get a little bit creative with it. We know that angle measures 80 degrees, and y isn't totally on there, and 40 isn't on there either, but what if we put those two angles together? We can use our angle addition postulate and do y plus 40 and make our other angle that sits on this transversal. So this might be something that you want to redraw if you're having a really hard time not seeing that angle in there. So you could just take this and draw your parallel lines and draw this single transversal, and that one's 80. Need a little more space here to work. Squishing stuff together in math never ever works out very well. All right, there's our 80, and then what's going on here? We've got y and 40. Isn't that a little bit easier to see if we mark that as our transversal, that we want to add y and 40 together there to make our other angle? And then what types of angles do we have? I see same side interior. Do you see that this and this are the same side interior angles? So we use our angle addition postulate to add together and make one of our interior angles, and then we can use our same side interior angles and say they are supplementary, and then this is actually definition of supplementary that lets us do this, and substitution. Hate it when they leave out substitution properly. Hate it when they leave out steps. There's 3 steps missing here. We would say the measure of angle 1 plus, there's only 1 step missing. Measure of angle 1 plus the measure of angle 2 equals 180 degrees. That's our same side interior angle theorem. Right, that's that. And then we don't need definition of supplementary. This is simply substitution property. And then we combine our like terms, just simplify and subtract 120 from both sides. That's our subtraction property of equality. Oh, again, I hate it when they don't follow their own rules. All right, so that's how we would put those together. Go ahead and pause the video, do the last problem here. I am going to give you a hint. You can extend your lines, all of them. And don't forget to mark parallel. And I would redraw, making things easier to see. I'll check back with you in a second. All right, let's finish this up. What I did was I broke my figure into two separate figures, and over here I drew my parallel lines top and bottom, and I drew my left transversal and labeled my angles, and I could see that I had same side interior angles, and I know that if I have two parallel lines cut by a transversal, that same side interior angles are supplementary. So I knew that I could just simply add the two angles together to equal 180. I solved for x and then substituted x back in, and I got 128 degrees and 52 degrees. And if I check this, yay, that adds up to 180 like it's supposed to. All right, and then I went and did the other side. I did my two parallel lines and my right transversal and labeled my angles. And again, I noticed that I have same side interior angles. And I know they are supplementary. Did the same work. Got y equals 40, substituted back in for y, and got 120 degrees and 60 degrees for my two angles. And again, I check it, adds up to 180. So I could just go up here and I could label my angles 128 degrees, 52 degrees, 120 degrees, and 60 degrees. And so I found the values of x and y and found the measures of my four angles. Now you saw on all of these that the requirement is two parallel lines cut by a transversal. And as soon as you have that, you have all four of your special angle pairs corresponding, same side interior, alternate interior, and alternate exterior. And they all have their special properties. Three of them are congruent, and same side interior is supplementary. And don't forget that we have our already special angle pairs, vertical angles, and linear pairs, which are congruent and supplementary respectively. So lots of good stuff when you have parallel lines being cut by a transversal. Do not hesitate to redraw and label to make everything more visible. And don't forget, if you're having difficulty and you're trying to compare it to the example in your notes, sometimes just turning the paper so that everybody's facing the same direction can be a huge help. So good luck with these. This is one of my favorites. As I said, parallel lines are a ton of fun. We are going to use them regularly. So get to know these special angle pairs and have fun with that homework.